Okay, so what we're going to do is we're going to continue on with problem solving using trigonometry. And so here, well, it doesn't look like it right now. So this is a river. So we got water in here. Maybe there's a sailboat here. Okay. But anyway, so we got a river going across here. It's a fairly wide river. And you're on one side of the river. And let's say we want to know how wide this river is. So how do you do that if you can't get across the river, or you can't measure? Let's say there's no road here, no bridge. Let's say for some reason you need to know how wide it is. Now, there's stuff on the other side of the river. We're going to use trigonometry. Now, trigonometry is study of triangles, and we're using SOHCAHTOA, right? So we have SOHCAHTOA. The problem is we don't have any triangles. So what you want to do is you want to figure out a way where you can use these triangles. And so one way to do that is find something on the other side of the river that you can use to help make a triangle. So, I mean, what I'm getting at is that we have different things you can sight on. You can look at this tree, like find some landmark that you say, okay, well, that's the one I'm going to use. I'm going to use this tree right here. Okay, so that means what I'm going to do is I'm going to start off by drawing a triangle. So I want to go straight across the river. Now it looks like, so I'm going to move from here to here. So I'm not going to stand there anymore. I'm going to stand there. So there's straight across that river, and I'm looking straight at that tree. And from here, I can go anywhere I want. I can go this way, this way. I'm going to move straight down the river like this. And the reason I'm going to do that is that by doing so, that forms a 90-degree angle. And we aren't there yet, but we're getting closer to having a triangle. So, and this is the nice thing about moving this distance is this is all on land where I can measure something. So let's say I measure out 100 feet. Okay, so I could measure a short distance like 5 feet or 10 feet, but the longer the measurement that I can make accurately, the more accurate the final estimation is going to be as far as how far across the river. We're not going to talk about that right now, but that's something you want to keep in mind. You wouldn't want to measure out 5 feet for a wide river. You might want, so let's say we do 100 feet. And then from here, you stop and you look at that same tree that you picked out before. And you make a sighting to the bottom of the tree. And now we can measure that angle right there. We'll call that angle alpha. And let's say that angle is, looks like about 55 degrees. Okay? So now what we have is something that you should be able to easily recognize. Now, what we're trying to find out is the distance from here to here, right? If we're standing right on the edge of the river, then that distance right there is going to be x. Okay, that's what we're trying to find. This distance we measured off, we know what that is. It's 100, and this distance is 55. I mean, not 55. This angle is 55. So you look at what we have. That side right there is the opposite side, opposite of alpha. This side right here is adjacent to alpha. And so we have O and A, and that's TOA. So that's tangent. So tangent of the angle, 55, equals the opposite, which is x, divided by the adjacent, which is 100 feet. We want to get x by itself, so we're going to multiply both sides by 100 feet. And that cancels. And you're left with 100, let's see, 100 times tangent 55, and that gives you 142.8. Now let's go ahead and round this one off to the nearest tens place. Not necessarily the most accurate estimate. We call that about 140 feet. Okay, now, so that's how you can do this. Now, one of the most important things I want you to kind of keep in mind is how we did it, and to understand, that at the beginning of this problem there wasn't even any triangle in the picture. So applying trigonometry in problem solving, quite often there won't even be a triangle. You have to look and think about how you can apply it and maybe add a triangle in there, or draw your own triangle based on sight lines or things that you're going to like that. Like for instance, let's say, measurements like this, can be very important. In everyday life, you see people working in construction on the road when they're, doing construction on the street, and they have to dig holes in the street. Many of those holes, if they ran into a gas line, they could blow somebody up. Somebody could die. And so it's important to know exactly where things are in different measurements, and especially over long distances. There might be barriers in the way that they can't measure exactly where they are, so they have to be able to use surveying tools and trigonometry to figure out where different things like electrical lines, sewage lines, water lines, gas lines are underground. Here's another method that you could do on your own if you wanted to someday. Let's say there's a building and you want to know how tall that building is. It's a tall building. It's a skyscraper, multi-story building. And we see this building, and you're over here thinking, how tall is that? Okay. Well, what do you know? Well, you know it's pretty tall. You can't reach the top. And there's no way that you can really accurately measure that building directly. So you have to find some other way of doing it. Now you're standing here. That's the building there. What do we know? We know there's a distance there. The height that we don't know, but it's straight up and down. If you look at how it meets the ground, there's a 90-degree angle. Okay? And you're standing over here looking up at it. Well, if you think about how that looks as you look up, it forms an angle with the ground. So if you knew a few more pieces of information, you might be able to find out how tall that was. So could you measure that angle? Well, you could make a very simple instrument with a protractor and you could measure that angle. So let's say that angle is 40 degrees. Would it be possible to find out how far away from the building you are? Sure, you could measure that off. How accurately you measure that will determine how accurate your estimate's going to be. But let's say you have a really long tape measure, and it's you can measure this as 200 feet from that distance to that distance. Okay, so what do we have? There's the opposite side, the adjacent side, and we have that angle 40 degrees. So looking at what we had above, so Katoa, what do we have here? Opposite and adjacent. That's tangent. So this problem would be done exactly the same way that we did the others. So we would end up with tangent 40 equals x for 200 feet. And then you multiply both sides by 200 feet. cancels, and you're going to get something like, let's see, 200 times tangent 40, and that's going to give you 167.8 feet, and let's round that off to the nearest tens place. So that'll be about 170 feet. And I guess, okay.